Welcome to Cyberpunk room build series, where I'm slowly transforming my tiny office room into something out of Blade Runner or Neuromancer lore. This is episode 4 and today I'm building a wall-mounted multi-purpose arcade console. The goal is to create a central hub that can control my smart home via Home Assistant, double as a custom arcade machine, and remain modular enough for future projects. Like always, the main construction is built with aluminum extrusions. The highlight of today's build is the use of sheet metal services from PCBWay to make the body of the terminal and test different material finishes. I will also be sharing a small online tool I made for designing the looping animations for small LED matrix displays to match the Cyberpunk vibe. Like always, all the code, plans and 3D files are available for free on my GitHub. You can find the links in the description. Let's get started. To better manage all the screws and nuts for this and future builds, I first mounted a couple of IKEA pegboards on the wall next to where the arcade console will go. To connect the extrusions to the 3D printed parts or anything else, I first need to tap the ends of each piece. Lubricating the tap is essential. Keeping the lubricant in a small container like this is very practical, as you can clean off the metal shavings and re-lubricate the bit in one quick motion. The frame of this build is pretty simple. I will be using only 2020 alu extrusions and have a limited tight space to fit it next to the entrance door. Luckily, this is a new drywall we built with a double layer of OSB boards behind them, so the first two 2020 extrusions, which will carry the load, are simply mounted with a few large wood screws to the back wall. As with any project, the core components constrain the design, so before finalizing the designs and proceeding with the build, I ordered the screen for the terminal. Finding an industrial-style monitor on a budget is tough, but I managed to find this one on AliExpress. It features an all-metal case and can be easily mounted to the 2020 extrusions with M5 screws using the included mounting ears on the sides. Now that I could confirm that the monitor fits perfectly with the extrusions on the wall and the spacings are right, I could finalize the designs in Plasticity, which is the CAD software of my choice, and proceeded with the build. When mounting this crossbar, I later realized that these corner brackets are not enough to provide the stability I wanted, so later I put a hole through the middle of the alu extrusions and screwed it in place there. Around this time, I received an email from PCBWay. They were interested in supporting my next project by offering some of their services for free. I gladly accepted as no money exchanged hands and they had no editorial control over the project or the video. More importantly, I had been searching for a way to fabricate the console body since local CNC services were well out of my budget. Luckily, PCBWay offers a sheet metal service, including CNC laser cutting and bending for the sheets for a wide range of materials and finishes. Considering the available materials and finishes, I finalized my design in plasticity. I placed the individual panels as individual orders to try out different materials and the glass bead finish, which is something I was especially interested in. Being totally unexperienced with these fabrication processes, I used this as an opportunity to learn more about bending of the metal sheets and made 2 front panels overlap using just small bends. Turns out it was simple as providing a 3D file to PCBWay order, and the additional cost was minimal. Shipping and import tax to Germany were surprisingly high, but PCBWay took care of those costs as well. The parts were packaged really carefully, especially the larger side panels, which came in a custom wooden box. Here's an example of glass bead finish on stainless steel plate. And this is a raw stainless steel plate. This is the wooden box I was talking about to protect larger and more fragile side panels. This is the right side panel, which I ordered as a thick acrylic plate, which is supposed to fit in the slot of the 2020 extrusion. And the left side is a very thin aluminum plate, which is just screwed on top. My Bedlington puppy was also excited to see if the parts will fit. At this time I've decided to test the screen again, but now with RetroPie installed on Raspberry Pi and the controls I've bought for the arcade. Since everything worked as expected, I've installed the big joysticks and the buttons on the steel plate and installed it in its final position. Since this project was taking way too long, I kind of rushed my order with PCBWay and didn't include all the holes for the buttons and other elements in the control panel I actually wanted. So I had to modify it a bit and include 3 additional buttons, at least for the start, to include the select start and a special button for the RetroPie. Drilling without a drill press made the buttonholes crooked, but I will cover it with different parts later. Later down the line, I do plan to include a 60% mechanical keyboard to display it, because I plan to use it for Home Assistant and a couple of other applications. Here's an assortment of different buttons I was able to find on AliExpress. They were all pretty affordable and are very interesting in shapes or other properties to use in similar builds. Fill the white wall between the console and doors, I looked through my inspiration notes and figured it is a perfect opportunity to finally try making the Ennis tiles. For anyone unfamiliar, this is the Ennis house designed by the architect Frank Lloyd Wright in the Mayan revival style. The house has been used as a filming location in Blade Runner and many other movies. I personally love how the Mayan revival style of Ennis tiles matches the cyberpunk aesthetics perfectly. Also, I wanted to try designing something similar myself, and this was a nice starting point, since I needed a light switch design in an irregular shape that matches the tiles. It took me a couple of iterations, but I'm happy with the final result. As always, the 3D files are open and linked in the video description. I've mounted the tiles simply using a double-sided sticky tape. Also making sure to leave some space between the tiles and the door frame so I can later make a more interesting door frame with electronics in it. The original idea was, of course, to just print the tile itself, to make a silicone mold, and then maybe attempt making it with concrete or something else. But I was so happy with the first print of the tile in the cheapest dark gray PLA that I just stuck with it. In one of the next videos, I will extend this console over the ceiling, where all the electricity and data lines will be placed. But to finalize this build in a half-decent shape, I decided to install these metal wire casings for the temporary lines, which can be easily reused later for controls on the other side. The upper part of the console will stay pretty empty for now because collecting all the parts and finalizing the plans was taking way too long. The final component to the console is a cheap LED matrix strip sign I found on AliExpress. It's programmable using GIF animations, so I developed a little self-contained online tool for generating glitchy Cyberpunk style animations. It's linked in the video description and you can run it locally as an HTML file or on my GitHub page. It has many useful features. On the right side you have some pre-saved examples and a random animation generator, as well as export and share options. On the left side you have all the parameters, main being the canvas you're using, so this depends on your LED matrix sign. You can use different frame rates, animation lengths, and also resolutions. Also, for the content of animations, it's built up in layers, so you can use scrolling text, different style of glitches and noises. You can add matrix rain symbols, you can use different fonts, etc. Also, you can set colors of every individual layer. The main feature of this tool is that whatever animation you generate, it always loops perfectly when exported in the GIF, so it works nice with your sign when you set it. It has different effects and they're all easily combinable and configurable. As you can see on my particular sign, the individual pixels are much smaller and there's a significant padding between them. This means when you're developing the animation in the tool, it doesn't really translate perfectly. So I added this feature as well. In the preview configuration, you can choose a different setting where the padding between the individual pixel is significantly larger, so you can appropriately adapt your animation for your particular sign. The animations can be exported as a GIF file or shared directly as a parameterized URL. The LED matrix I have is very flexible because it was originally meant to be used in the car. So I 3D printed different brackets and holders to position it in place on the console. Hope you enjoyed this episode. Thanks for watching and don't forget to subscribe.